Okay, so this review is for my Algebra 2 students. We do have a quiz coming up on 6.5 through 6.8. So here are 8 problems that you should know how to do. So this problem says, and I'm going to rewrite it because that exponent is small, 3 times x plus 3 to the 3/4 equals 81. Okay? And when you approach this problem, this has a rational exponent. So put a box around the base and the exponent. So the 3 is over here, not inside the box. Get rid of it by dividing. Divide by 3. And now we get x plus 3 to the 3/4 equals, and 81 divided by 3 is 27. And now that the base and the exponent are isolated, we raise both sides to the 4/3 power. That is the reciprocal. Okay? And these exponents cancel, and x plus 3 comes down. Now, because this 4 was even, we should put the x plus 3 in an absolute value. The even exponent might create 2 solutions. And then this you can type in the calculator, and remember, use the caret button. 4 divided by 3. And when you do that in the calculator, you should get 81. Okay? Alright. And now, this is your equation. Absolute value of x plus 3 equals 81. And there are 2 equations that you do. X plus 3 equals positive 81, and x plus 3 equals negative 81. And you solve each equation. Subtract 3, subtract 3. We get x equals 78. Subtract 3, subtract 3. X equals negative 84. And now we must check. Always check your work. So I'll check the 78 first. 3 parentheses 78 plus 3 to the 3/4 equals 81. This right here is 81 to the 3/4. And 81 to the 3/4, if you type in the calculator, you'll get 27. And 3 times 27 is 81. So 78 works. Okay, so for the other one, I'm going to do it right below. We'll plug in negative 84. 3 times negative 84 plus 3 to the 3/4 equals 81. 3, parenthesis, this is negative 81 to the 3/4 equals 81. And the issue here is the following. When you type this in the calculator, it's going to give you an error message because that is the index. Your index of your radical. Remember, rational exponents and radicals are essentially the same thing. So if I take the 4th root of a negative, I do not get a real solution. So this will not work. And that means that is not an answer. So there's only one answer to this problem, 78. Alright, so just be aware of checking your solution, and remember that the denominator is the index, so be careful there. Okay, next here. So now we're taking a look at a radical equation. This has a square root in it. And the first thing you do to attack this problem is you put a box around the square root. And I notice that this minus 5 is not in that box, so add the 5 to both sides. So the square root is now isolated, square root of 3x plus 13. And on the right side, when you add the 5, this just becomes x plus 5. And now we raise both sides to the index. The index is a 2 because it's not there, so we square both sides. And notice the right side, how I write it. X plus 5, that parenthesis squared. On the left side, the radical cancels, and we get 3x plus 13. On the right side, we have to write this as x plus 5 times x plus 5, and we have to multiply it out, distribute it out. X times x is x squared, x times 5 is 5x, 5 times x is 5x, 5 times 5 is 25. And now I will simplify the right side. 3x plus 13 equals x squared plus 10x plus 25. And now we need to make everything move to one side. So let's subtract 3x. Let's subtract 13. This left side becomes 0, and the right side is x squared plus 7x plus 12. And now this is a quadratic, which we are going to use the B and the C to solve for. So if I look here, C is 12 and B is 7. Now again, A is 1, so we can just ignore it. And now we're looking for the factors of 12 that make 7. And the factors of 12 are 1 and 12, 2 and 6, and 3 and 4. Now, because this 12 is positive, that means your signs are the same. So they're plus plus or minus minus. You notice that the B is positive, so it's going to be plus plus. So we do plus plus, positive 1, positive 12 is positive 13, not what I want. Plus plus, you get positive 8, not what I want. Plus plus, you get 7, that's exactly what I want. 3 and 4 are the numbers that go in my parentheses with x's. So this thing factors into x plus 3, x plus 4. And to find the individual x values, we set each one equal to 0. X plus 3 equals 0, x plus 4 equals 0. Subtract 3 on both sides, x equals negative 3. Subtract 4 on both sides, x equals negative 4. And there's our potential answers. But we're not done until we check. We need to check our work. So we'll plug in these numbers. So if I plug in negative 3, notice there are two x's, so the check. Oh, where's my equation? There it is. Okay, so it says the square root of 3 times negative 3 plus 13 minus 5 equals negative 3. 3 times negative 3 is negative 9, plus 13 is 4. The square root of 4 is 2. And 2 minus 5 is negative 3. This works. Okay. I'm going to scroll down to check the other one too. Square root. This is 3 times negative 4 plus 13 minus 5 equals negative 4. Remember, the x goes twice. 3 times negative 4 is negative 12 plus 13 is 1. Square root of 1 minus 5 equals negative 4. The square root of 1 is 1. 1 minus 5 is negative 4. And there we go. So both work, because when you check them, they both work in the equation. Alright, so just make sure you check. And those are the solving ones. Okay, next problem here. We're going to do some operations with functions. So we have f and g are given. We need to perform each operation. And this is g minus f. Okay? So this is subtraction. So we put g first, x minus 1, and then because it is subtraction, minus, and I open a parenthesis, and f goes in here, 2x squared plus x minus 3. And now I need to know to distribute that negative sign. X minus 1 minus 2x squared minus x plus 3. And now I'll just combine like terms. The 2x squared is the only one. X minus x, oh, they cancel. So there's no x involved. And then negative 1 and positive 3 is positive 2. And there's the subtraction. Okay. Next we have the division. And for the division, we just stack them on top of each other. 2x squared plus x minus 3 over x minus 1. And I said be careful for the factoring. I bet you that top trinomial factors. And notice that the x minus 1 is on bottom, so I bet you one of the factors is x minus 1. So we need to figure out what other factor will give us 2x squared plus x minus 3. Well, if this is x, these two terms have to multiply to get me 2x squared. So if this has the x, this must have a 2x, because x times 2x is 2x squared. And then the last is gotten by the negative 1 and this number. I want to make a negative 3. So what times negative 1 gives me negative 3? Well, that would be a positive 3. Negative 1 times positive 3 is negative 3. Okay, and there's your factoring. And notice the x minus 1s are the same on top and bottom, and your solution is 2x plus 3. And there we go. Alright, so with the division, be careful for the factoring. And remember, we're ignoring the domain. Don't worry about this domain part. Okay, 4. Composition of functions. Here we go. Here's my f, here's my g. Figure out what this is. F of g of negative 2. F of g of negative 2. Notice what it says to do first. G of negative 2. Do it. G of negative 2 means plug negative 2 into g. Negative 2 minus 3. Negative 2 minus 3 is negative 5. This is what g of negative 2 is. So now we take that number, negative 5, and plug it into f. F of negative 5 is negative 5 squared. And that is 25. Next one. For the function, find the inverse. We're going to ignore the domain and range, so find the inverse, and then determine whether it's a function or not. Okay? So here's what we're going to do first. We're going to find the inverse. So here's my function. F of x equals the square root of x minus 5. I will change f of x into y, and I will now switch x and y. And now I'm in charge of solving for y. Now notice on this right side, the y is inside of a square root. This square root is the only thing over here, right? There's no number in front, no number added or subtracted on the outside, so we must get rid of the square root. This is a squared, so we square both sides. And we get x squared equals y minus 5. And now to get y all by itself, we add 5 to both sides. X squared plus 5 equals y. And finally, notation. F inverse of x equals x squared plus 5. Okay, and now I want to determine if this is a function. Is this inverse a function or not? So what I'm going to do is I'm going to graph this. Now, if you don't know how to graph this, you should pick some points and plug them in. Now, for this one, we should know how to graph it because it is a square root graph. So we've been talking about these. So we're going to graph it like this. Create my xy. Go about 5 in every direction. So first thing I want to do is to graph these, I want to think of the parent graph. And maybe you want to put it off to the side this time. So I'm going to put the parent graph right down here. So this is going to be y equals square root of x. This is my parent graph. And remember the points are 0, 0, 1, 1, and 4, 2. Right? So what does this minus 5 mean? This minus 5 means move your graph to the right 5. So up here now, okay, I'll do it in blue, the original function, we're going to move these 3 points to the right 5. So 0, 0 becomes 1, 2, 3, 4, 5, 0. 1, 1 becomes 1, 2, 3, 4, 5, 6, 1. And 4, 2 now becomes 1, 2, 3, 4, 5, 10, 2. And look, I didn't put enough lines. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10, 2. So there is the function f, and it should be curved a little bit more than that. Curve it. It's bad too. Sorry. Here we go. Yep, there's f. So now I want to graph the inverse. Well, remember to graph an inverse, you just switch the x and y. This is the point 5, 0. This is the point 6, 1. And that's the point 10, 2. So we switch x and y to get our new points for our inverse function. 5, 0 becomes 0, 5. 1, 2, 3, 4, 5. 6, 1 becomes 1, 6. 1, 6. And 10, 2 becomes 2, 10. 6, 7, 8, 9, 10. 2, 10. And there's your inverse. And notice what it is. It's half of a parabola. And that's sort of what we've been talking about, is that the square root graph and your x squared graph are the inverses of each other, because that's what you use to cancel each other out. However, when you do a square root, you should only have 1/2 of it. So when you do the inverse here, you're only going to have 1/2 of the inverse. And notice, if I draw a vertical line through this graph, only touches once. This inverse is a function, yes, because passes the vertical line test. Okay, so remember, to graph a function in its inverse, graph the function, then switch x and y to graph the inverse. Then check to see if the vertical line test passes. If it does, then you do have an inverse. Okay. All right, good. That's a toughie. That's a lot of work right there. All right. Okay. 6. Here we go. We got a formula here. We want to find the inverse of this formula. This formula says v equals 4/3 pi r cubed. And what I would like to do is I would like to get the inverse, which means get r alone. That's my goal, is to somehow get r by itself. So the first thing I'm going to do is I'm going to put r cubed in a box. Right? That's the base and the exponent. Get r cubed alone. So I don't like this 4/3. So to get rid of this 4/3, I'm going to multiply by its reciprocal, 3/4. 3/4 v equals the 4/3 and 3/4 cancels, pi r cubed. And now, again, still get r cubed by itself, divide by pi. Divide by pi. And I don't care how it looks. You can leave this alone. I don't really care at all. Okay? So why don't we just do that? So 3/4 v divided by pi equals r cubed. And now that the r cubed is alone, to get rid of this cubed, we take a cube root. And we do it on both sides. So the cube root of 3/4 v divided by pi equals r. And that is the inverse. So now, we need to figure out, okay, use the inverse to find the radius if the volume is 35,000 feet cubed. So now, for part B, we're going to take 35,000 and put it in for V. Cube root of 3/4 times 35,000 all over pi equals R. And I need to simplify this, okay? I'm going to scroll down here for a sec. So what I will do is I will do the inside in my calculator. So I'll do 3/4, and I'll just use 3/4 times 35,000 divided by pi. And inside that cube root, I get 8355.63. That's fine. And I will take the cube root of that. And remember, to do that in the calculator, you must do, so to do this in the calculator, 3 and then that x root button, which is a second. So you must type in 3 and then an x root. So the cube root, so 3, and then I'll do the x root, and then I'll type this number, 8355.63. And I get 20.3, and there's my radius, 20.3. And this volume was in feet cubed, so the radius is in feet. That's a tough question there, for sure. Alright? But just remember, if you have multiple variables, not x and y, but multiple variables, like v and r in this one, get the one that's not by itself. And to do that, just use inverse operations. Alright. Okay. 7 here. We're going to graph the function. Alright. And you notice this is a cube root. Maybe you can't see. Let me rewrite it here. Y equals 2 cube root x minus 6 minus 9. Okay? So the first thing I'm going to do is I'm going to graph the parent function. The parent function, I'll do it in blue. Y equals the cube root of x. So there are 3 important points, and I'll do it right down here. Those 3 important points are 0, 0, 1, 1, and -1, -1. And remember, it looks like 2 square root graphs connected. So now I need to look at this function and do the 3 transformations that it says to do. First, a is 2, which is bigger than 1, which means a vertical stretch. So 0, 0 remains in the same spot. But now the point 1, 1 will turn into point 1a, which for us is going to be 1, 2. So it's going to grow up higher. And the point -1, -1 is going to go to -1, -a. So it's going to go -1, -2. And it's going to grow lower. And you see what happens. It got stretched. Okay? And now finally we do the movement. Okay? We do the movement here. And the movement is the -6 and the -9. I'm going to do it right down here. That -6 inside means move to the right 6. That -9 on the outside means move down 9, right? So the inside is left or right, opposite of what it says. The outside is up or down, exactly what it says. So these 3 points in green, I'm going to move to the right 6 and down 9. Now that 9's a little ridiculous. So how about we change this 9 to a 4? Okay, can you do that with me? I don't want to go down 9. So we'll go to the right 6. So 0, 0. 1, 2, 3, 4, 5, 6, and then down 4. There's my 0, 0 point. 1, 2. 1, 2, 3, 4, 5, 6, and then down 4. 1, 2, 3, 4. And then -1, -2. 1, 2, 3, 4, 5, 6, and then down 4. So again, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. So I'm down here somewhere. And again, there's the picture. So this is a little tough because of the not having a graph, but hopefully you get the gist, right, of how it got vertically stretched and then how it got shifted left and right. All right. So be aware of the values of A, H, and K in your problem. Okay. And then finally, last one. Here we go. Let's rewrite this equation so it's easier to graph using transformations and describe them. Okay? So this is a square root graph. So the issue is this 25, right? That's not A, H, or K, right? The formula says A square root of x minus h plus k. There's no number in front of x, so let's get rid of it. Let's see if we can pull it out. So we're going to factor it. Y equals the square root. 25 can be factored out because 25 goes into 125, and it goes in there 5 times. And now, since this is a square root, is 25 a perfect square? The answer is yes. 25 is 5 squared. So now this 5 can come out because it is squared. And when it comes out, the x plus 5 is left in its place. Notice when it came out, no more squared. And now we need to describe these transformations. Now it's A, H, and K. So what is happening here? So number 1, A equals 5. That's greater than 1. That's a vertical stretch. And then number 2, the plus 5 inside means shift. And that's going to be to the left 5 because it's positive. Go opposite. And that minus 3 means down 3. And there's your transformations. A vertical stretch of that factor of 5, which is what we pulled out, and then we're shifting right, left 5 and down 3. Okay. So hopefully this video helps you prepare for the quiz tomorrow, and we'll see you tomorrow. Thanks for watching.